Hello everybody, in this video I'm going to be going over some quick logarithmic identities that are extremely useful for any sort of exponential problem. Now the first thing that we're going to do is define what log basically means. So let's say we have the equation log a of b is equal to x. This means that we can rewrite it as a to the x equals b. So basically, if you have an equation like this, you use logs to solve it. For example, what you could do is take log a of both sides, and you'll go back to your original equation. And so basically what log a of something means is, to what power do you raise a such that it becomes the number right here? Now that we've got the definition of logarithms down, we can start with some simple logarithmic identities. The first one that we're going to start with is log a of x plus log a of y is equal to log a of x times y. And the reason why this is true is because if we simplify this to the exponential form, so this, let's say it's equal to some number b, and this is equal to some number c. Well, then we know that a to the b is equal to x, and a to the c is equal to some number y, by the property of logarithms we defined before about converting exponential form to logarithmic form. So now that we have these two down, let's multiply them together. We have a of b plus c is equal to x times y. And if we take the logarithm of both sides, we have log of a of b plus a to the b plus c is equal to log base a of a to the b times c, b plus c, is equal to log a of x times y. And if we simplify this, we have b plus c is equal to log a of x times y. And therefore we have our original equation because we define b and c to be these respective. Now it turns out you can do a similar thing with subtracting logs. And this is what you get. Instead of multiplying, it divides. And this is also pretty easy to figure out if you assign values to these and convert to exponential form and do some manipulating. Now this next one is known as the change of base formula, and it is also a pretty common identity, and it's really useful if you only have a scientific calculator and you don't have an advanced graphing calculator that has the function of being able to change the base, because most scientific calculators only offer bases of 10 and bases of e. And log base with a base of e is usually referred to as ln, not log base e, and it's known as the natural log. This is known as just any log. It's a normal log that you take and it's base 10. So we have this change of base formula, and it's extremely useful for just changing the base. That's why it's called change of base formula. Now this next one right here is just the bonus identity I decided to add here, and it's just based off the change of base formula. And there's a really simple proof for this. We have log a of x over log a of b of x, and you can use the change of base formula on this, so this can become log a of x over log a of b, and you can verify this using the change of base identity, and this is equal to 1 minus log a of b, and this goes to log a of x times log a of b over log a of x is equal to 1 minus log a of b. So these cancel out and you're left with this on this side. And by our simple property that we learned earlier about subtraction of logarithms with the same base, we have log a of a minus log a of b is equal to 1 minus log a of b, and this simplifies to 1 log a of b equals 1 minus log a of b. And this is true because this right here, a to the first power is equal to a. So this is why it simplifies to 1. So thanks for watching. I hope you enjoyed this video about logarithms. I'll be making more really just topic focused videos soon, so be sure to check those out. Thanks for watching.